Hi class, Mr. Scheidegger here. This is your review for chapters 3 and 2, these sections that we've done. What I'd like to do is go over each section one by one and give you a sense for what you need to know in each section, and I will provide some examples and in addition give you some questions from the book that you can practice to improve your skills before the test. This test is going to be covering sections 3.1, 3.1 to 3.5, and 3.7. In addition, you have from Chapter 2, Section 2.1, 2.2, and 2.4. So quite a bit of material that we have there, looking like 9 sections of material. Some of the earlier sections, though, are just practice for what you see later. So you're likely not to have to spend as much time on them. Let's go first to section 3.1, and on 3.1, you're responsible for linear equations, and mostly just how to plug in points and recognize what a linear equation is. Linear equations are any equation that has just typically 2 variables. It can have just one. For instance, we can have x equals 1 or y equals 3. But in the form that you were seeing it in the book, things like 3x plus 2y equals 6 is an example of a linear equation. One of the things that we had to do in chapter 3, section 1, was to be able to figure out which points might work in these equations. So for example, in this equation, you might notice that if I plug in 0 for x and a 3 in for y, I have a point that solves this equation. So on section 3.1, you really weren't asked to do very much more than be able to identify what a linear equation looks like and be able to plug in points. Another example is on page 104. Let me just give you one type of a question that you should be able to deal with is 5x minus 2y equals 7. And the question asks for you to plug in a value for x. So if you have an x value of -3, the question is, are you able to find out what the y value is? To do that, you would plug in the -3 into the x value, minus 2y equals 7, and then solve for y. -3 times the 5 is going to be -15 minus 2y equals 7. And sorry about that. And adding 15 to both sides gives us -2y equals 22. And dividing both sides by the -2 gives me y equals 11, which we simply put inside the box here, and we're done. Okay, so if you look on page 104, I think that you're going to get the idea of what you need to do. Let's move on to section 3.2. Here in section 3.2, we have graphing lines from standard form. And I'm going to say graphing lines from standard form. A lot of you guys need to know what forms are which. There are three forms of the equation that we're going to be using, but they were introduced at different times. And so when we're going to be graphing using standard form, an example would be, I'll give you as simple example as I possibly can, it'd be 2x plus 3y is equal to 6. And when we have, this is a standard form equation. Standard form means it's in the form of, I'll just go ahead and write it over here. It's going to be some number followed by an x plus some number followed by a y equals some number. And so we say it's in that shape of ax plus by equals c. To graph a line in standard form means to do what I was calling the cross-eye method. This is going to give us what we call the x and the y intercept. So the cross-eye method basically means that we're going to find two easy points. The two easy points are found by either letting y equal to 0 or letting x equal to 0. And that's what I'm doing here by what I'm referring to as the cross-eye method, is putting the 0 in for the y and the x. If the 0 is there if I put a 0 in for the y value, then the 3 times y becomes 0. And I'm just left with this 2x equals 6. So what does that mean? 2x equals 6. If to solve for x, I divide both sides by 2, and I get a y equals 3. Sorry about that. I get, y equals 3. Go to the next value, the next point, and it's asking me to make x equal to 0. When x is equal to 0, then we have the 2x being lost, and now I have 3y equals 6. 3y equals 6 means that 1y is going to be equal to 2. This first point is actually called the x-intercept because it's showing us where the line crosses the x-axis. So it's worth knowing that in the cross-eye method, the first point is the x-intercept, and that leaves this one to be the y-intercept. How do we graph this line? We're just going to make our coordinate axis, and I have 3, 0, means I move 3 along the x-axis, and I draw a point. That's my x-intercept. And then I go 0, 2 along the y-axis, and this becomes my y-intercept. I connect the line, I connect the dots to create the line. Okay, so this is something that you do need to be able to do. I'm going to ask you on the test. I would like to be able to ask you on the test. I can tell you what the questions are. What are the x and y use the x and y intercept form to graph a line in standard form. So you should be able to try to do that on your own. Let me give you an opportunity to practice that on the next page here. Let me give you a problem, and what I'll do is have you try to graph it. And pause. I want you to pause the video and graph it, and then turn the video back on, and I'll show you very quickly how to answer it. So here's your next. So here's a practice question for you. I'll try not to make it too easy, but 2x minus y equals 6. Two x minus y equals 6. So what I'm going to ask you to do is find the x and the y-intercept of this line and graph the 2 points and create the line. So why don't you pause for now and try to do that on your own, and when you're finished, unpause and you'll see the problem. I'll do the problem for you. Okay, so pause. Okay, welcome back. And very quickly, let's go ahead and do my cross eyes. And here we have y is equal to 0 when y equals 0. 2x equals 6. Therefore, x must equal 3. And when the x value is equal to 0, I have negative y equals 6. Therefore, y must equal negative 6. To graph this, create your coordinate axis and your y and x axis here. 1, 2, 3 is the first point, 3, 0. And then we have negative 6. It's going to be right here. And we'll just join the two lines, and that's it. One thing we need to add to this section, 3.2, is the vertical and horizontal lines. These are somewhat special case lines. Some of you seem to be really good with this, but just to review, we have an example might be x is equal to 3. In this case, this is most of you already know by now that this is a vertical line that goes through the point x equals 3, that x-intercept here. So be able to draw this line and its sister y equals, say, negative 2, where we have y and x, and in this case, again, it's going to go through the y equals negative 2 point. And for some of you, that rightfully means that it's a horizontal line. So be sure that you have those special case lines to do, that you can do. So if you guys want to take if you want to do some practice right now on this section, on sections 1 and 2, for section 1, I would recommend that you do page 104, and I'm going to be writing these later on. I'm going to write these again on our My Essay review sheet. So on page 104, I would recommend that you do 1, 15, and 23. Checking in the back of the book, these are all odd questions. And for this section here, this is again, this is 3.1. And then for section 3.2, I'd recommend you take a moment and go to page 111 and see if you can do find this graph using the x and y intercept. What we just did. And the two that I'd like you to do, the questions that I'd like you to do are 9, 13, page 111, 9, 13, 15, and 27. So that should provide you enough practice with finding the x and y intercept to be ready for the test. And we'll move on to slope next. But right now, if you're in class, I would recommend that you and whoever you're sitting next to execute these 7 questions and check the answers in the back and be sure that you understand what you're doing, because you're going to need these skills when we move on to other sections. So pause for now, and I'll see you when you turn this video back on. We'll get a 3. I don't know why I'm doing this. Welcome back, everyone. I want to move now to section 3.3, which seems to have an awful lot. So 3.3 is where we talk about slope. Inside section 3.3, we have, first of all, we have the formula for slope. M equals y2 minus y1 over x2 minus x1. Be sure to make that the y's are on the top and the x's are on the bottom. In addition to being able to find the slope from 2 points, this is also the section where they would like you to be able to find the slope by just looking at the equation in standard form. Again, if the equation is in standard form, ax plus by, sorry about that, then the slope of the equation will be negative a over b will equal the slope. An example would be something like negative 2x plus 3y equals 7. In this case, we're going to take the negative 2 and change it to positive 2, because remember, it is the opposite. That's what that negative sign means. So this should be 2 over 3. That's the slope. Another example would be 7x minus 5y equals 3. Again, we're going to take the opposite of the first value, so that's going to be a negative 7, and we're going to divide it by the second value, which is negative 5. So the slope is going to be negative 7 over 5, or 7/5. Now, give you some practice questions that you can use to see if you can't practice your skills for the test. So so we're going to be looking on page 116, and I would like you to look at 5, 9, 13, 15, 17, and 19. On these questions, I would like you to change the equations. Actually, the first few, all you're doing is finding the slope. You're going to be using the change in y over the change in x. That's going to be questions 5, 9, and 5 and 9. So number 13 and 15, what you need to do is use the negative a over b formula for finding the slope. Now be careful when you get to number 19. Number 19 is not in standard form, so you will need to move the 3y to the other side before you do the negative a over b idea there. The last thing I want you to do is to use point slope form to find the equations of number 25, 29, and 30. And again, I'm going to specify to use point slope form to make the equation. And then once you've created this equation, I am going to ask you on this one to change it to standard form. What I'd like you to do is to practice. Questions are on page 116. These should be relatively simple, but the first couple questions are going to ask you to find the slope of 2 points using the m equals y2 minus y1 over x2 minus x1. And then it also has questions 13 and 15, 17 and 19 are all questions asking you to use the negative a over b formula. Please use that. Do not convert to slope y intercept form. I'm going to expect you on the test to be able to figure this out otherwise. So please just learn this for now and try it and experiment with it, and then if you want to discard it, then go ahead and do that, I guess. The next questions are going to ask you to use this a point and a slope and a piece of graph paper to determine other points on the line. And so this is just an exercise to make sure that you guys understand how point slope comes about and how it works. So the questions that I would like you to do are on page 116 again, and I am looking at questions, it's on the paper here, 25, 29, and that should do it. So questions 25 and 29, you're going to graph and find the points, find 2 extra points. I guess just 2 points. All right. So I would recommend that at this point you go ahead and take a break from either your work or at least from this video, and see if you can't do these questions. So if you can pause this video right here so that you have the questions right there in front of you, and then when you finish them and check the answers with the back of the book, then once you go ahead and turn back on, because again, it's important that we know everything that comes before. Otherwise, the work that we're going to be doing later on is going to be a little confusing. So take a break now, or at least take a break from the video and try these problems. Okay, I'll hope that little exercise went well for you on 3.3. Now we're on 3.4. This is actually a really critical piece that you're going to see probably from here to the end of pre-calculus, and maybe then do calculus too. But section 3.4 is where we have finding the equation of a line. So up to now we are supposed to not know how to find the equation of a line. But of course you've done this before, so it should be at least vaguely familiar. The 2 things that we're going to learn are the point slope form of an equation, which we've been writing as the slope times x minus x1, which is the point value of the point that they're given, and then y minus y1. An example would be if I have a slope of negative 2/5 and a point for negative 3. This is right off page 118, by the way. What I can do is put the slope in here for m, put the x value of the point in here, and the y value of the point in here. Be careful, though, because there's a negative sign that we have inside the formula, which takes the opposite of the point values. So just plugging in the values, you will quickly create an equation of the line 2/5, and we'll have x minus 4. Try to remember, why is that minus? That's minus because the formula has a minus sign in it, equals y plus 3. The y point is negative 3, but the formula is telling me to take negative 3. So This creates our equation very, very quickly. If you have 2 points, you need to find the slope first, and then you plug in the point. To change this to standard form, which you will be asked to do at least once in the test, if it doesn't ask, don't do it. Don't waste your time, and I will hold to that. So let's change this to standard form. First thing is to multiply both sides by 5. Multiplying by 5 on the left ends up canceling the 5s, and we have a 5 over on the other side now. So we have 2 minus 2x plus 8 equals 5y plus 15. At this point, we need to put the x's and the y's on the left and all the constant values on the right. So I need to move the 5y to the left side. Doing so makes it a negative. So I have 2x minus 5y. Now I need to subtract the 8 from the left, move it over to the right. Subtracting 8 from the 15, it's going to leave me with 7. And as I've told you before, the book and lots of math teachers would like to see the first term being positive. If it's negative like this, it's not wrong, and I will not count it wrong on a test, but if you look in the back of the book, it's more likely that they're going to multiply everything by -1, leaving you with a 2x plus 5y equals 7. If we wanted to apply what we learned in 3.3 in the previous section, it would be interesting to say, okay, well, what's the slope of this? Just for the practice. What would it be? It's going to be negative a over b, which is -2 over 5, -2/5. Well, that's exactly what we were given at the very beginning. So just to not forget what we already learned. In addition to having this, having point slope form, which I'm going to test you on. I know you guys love slope by intercept form, but it's because you've used it so much. Point slope form is a great way to create the equation of a line, and if they don't specify how they want it on a test, then you can just leave it just like that. The other form of the equation that you guys seem to know pretty well is y equals mx plus b. Y equals mx plus b is the slope y-intercept form of the equation. What's nice about it is that it reveals the slope very, very clearly. And then the y-intercept is where it crosses the y-axis is that value for b. The primary reason that slope y-intercept form is introduced in this section is that we can create lines that are both parallel and perpendicular to other lines. One of the things that we need to know is that if two lines are parallel, then their slopes are the same. So this is line 1 and this is line 2. What happens is the slope for line 1 is equal to the slope for line 2. Now, an interesting thing happens when we have lines that are perpendicular to each other. Lines that are perpendicular to each other are going to have a different relationship. And the relationship is going to be that each line is going to be the negative reciprocal. The slopes will be the negative reciprocals of each other. So, for instance, if line 1, and I'll just call this one line 1 and this one line 2, but to say if line 1 had a slope of -2/3, line 2 would have a slope of 3/2. Again, what's going to happen is we take the opposite, we flip it, and we take the opposite to get the perpendicular slope. And I will apply that to a couple quick questions and give you guys a chance to practice these in a second. So here we go. Well, let's try, first of all, let's use the point slope form in some of the types of questions that you might be able to see on the test. If I have a question that says I have a slope of, I'm given a slope of 1/5, and I have a point for negative 3. And what I'm going to do is ask you to find the equation of the line and convert it to standard form. So that's the toughest type of question you might be able to get for this type of thing. Let's first create the equation. So it's going to be slope is going to be 1/5 x minus the x value, which is going to be x minus 4, equals y minus the y value, which is going to be plus 3. So multiplying both sides by 5 gives me x minus 4 equals 5 times y plus 3. And we can remove the parentheses on the left and distribute the 5. And our final step is to get the x and the y on the left and all the constant values on the right. So x, bringing the 5y to the left, makes it a negative 5y. And now we'll get rid of that 4 by subtracting 4 from both sides, leaves us with 11. So this is the equation in standard form. Two other things that you may be asked to do is find the equation of a line that's either perpendicular or parallel to another line and going through a certain point. These are found on page 121, and I'll take one of these, and you'll be able to practice with a few others. But we'll take number 36. And I think we've done this one already before, but hopefully it's been a while. So we have a point of negative 1, 2, and a line that is the equation x minus 3y equals negative 2. So on this one, the first thing we should do is try to find the slope. And if you remember from the previous section, the slope is going to be negative a over b. This question is in standard form, so let's go ahead and take advantage of that and quickly get the slope. M equals negative 1 over negative 3, which simplifies to 1/3. Okay, so now we have the slope, and now we have a point. And so we can immediately write the equation of the line that's parallel. Now, the equation of the line that's parallel to that line that was given must also have the slope of 1/3. In this case, though, it's going to be going through this point. So it's going to be a distinctly different line. It's going to be a line going through that point, but having the exact same slope. So the parallel line will be 1/3 times x minus the x value, which in this case will be plus 1, equals y minus the y value, which is 2. And that's the answer. The perpendicular line will be a slope. We take the 1/3, we flip it and make it the opposite sign. So it's a positive, we're going to make it a negative. 1 over 3 flipped is 3. So the perpendicular line will have a slope of 3, and then we just plug in the point again. X plus 1 equals y minus 2. Notice that the equations are very, very similar because we use the same point. The only thing that's different is the slopes. I am not going to convert these to standard form because we did those earlier. So if you're confused or can't remember how to do it in standard form, just go back a section and check that out. Now on to section 3.5. In section 3.5, we're talking about systems of linear equations. So 3.5, trying to get this thing to nail itself down. Okay. Is systems. In a system of linear or equations or inequalities is just more than one. There's three possible solutions to systems of linear equations, and I have those pictured here below. One of them is where we have the two lines, and this is probably the most popular one. We have the two lines crossing each other at one distinct point. If the lines are parallel, and if the lines are parallel, they're not going to share any common points, and so this is a situation where we have no solution, often written with the little circle and the line going through it. If the lines fall on top of each other, we call them coinciding lines, and we would basically say that they share all the same points. So the answer to a coinciding lines is that we have all solutions. And clearly, the latter two situations are a little more rare. We're more likely to find intersecting lines. Now, the way we're going to solve these, there's three methods that we solve systems of equations. One is by graphing. So solving by graphing, we graph the two and we see what points they share. The other is by substitution. And the final is by elimination. What I'll try to do is, what I'm going to attempt to do is give you one system of equations, and we'll solve it using all three methods. And from there, hopefully, you'll be able to catch on how to do this with your, with all other problems or the practice ones that I'm going to give you. So take a look at this. The equations I'm going to have are x plus minus 2y equals 5, and 4x plus 3y equals 9. To solve this by elimination, there's several things that I could do. I could multiply what I need to do, though, is make the coefficients of the y terms or the x terms the same. I can multiply the top, to get the y's to cancel, I could multiply the top by 3 and the bottom equation by 2. That makes negative 6y and a positive 6y. They would cancel. Or I could take the top equation and multiply it by negative 4. I'm going to choose to do that. That way I only have to multiply one equation. And I'm going to make sure that it's negative 4 so that the 4x cancels with that. So if I multiply both sides by negative 4, I'm going to get negative 4x plus 8y equals negative 20. And 4x, the other equation, doesn't change. Sorry about that delay there. The other equation doesn't change, is plus 3y equals 9. If I add both equations together, I get the x's will cancel, and I end up with 11y equals negative 11, y equals negative 1. Now, to find out what x is equal to, we're going to take this negative 1 and substitute it into the original equation. And we get x minus 2 times negative 1 equals 5. X plus 2 equals 5. Subtract 2 from both sides. And x is equal to negative 3. Please write the solution as an ordered pair, negative 3, positive 3. I did that. Sorry about that. Positive 3, negative 1. To do this same problem by substitution, so I will do the same problem so this is the elimination method. To do the same problem by substitution, what I'm going to do is let me copy down the problem again. Equals 5, and the 4x plus 3y equals 9. What I'm going to do is I'm going to take the first equation and I am going to solve it for x. This should give me x equals 5 plus 2y. Now substituting the 5 plus 2y in for x, I get 4 times 5 plus 2y plus 3y equals 9. So this is the same equation, second equation with the 5 plus 2y inside. Distributing gives me 20 plus 8y plus 3y equals 9. Putting the 20 on the other side, I subtract 20 from both sides. That's going to give me a negative 11 over here, and then I'm going to add the 8y and the 3y to get 11y. Y equals negative 1. If I take this negative 1, just like I did before, and I substitute it in to the first equation, I get x equals 5 plus 2 times negative 1, which is 5 minus 2, which equals 3. Again, write it as an ordered pair. We're going to have 3, negative 1. The exact same answer we had using elimination. So to graph this same thing and find the solve by graphing, what we do is we'll take the original two equations, x minus 2y equals 5, and the equation 4x plus 3y equals 9, and we'll put both of these equations in slope by intercept form because that's what most people like here. So putting the x on the other side, I have minus 2y equals negative x plus 5, and dividing both sides by negative 2, I'm finished with y is equal to 1/2 x plus 2.5. I should say that's a minus 2.5. Over here, on the other equation, I subtract the 4x from both sides. I get 3y minus 4x plus 9. 3y equals negative 4x plus 9. Dividing everything by 3, y equals negative 4/3 x plus 3. So if I try to graph both of these lines, and let's recall how to graph using slope by intercept form. We'll graph the first one. We're going to go to the y-intercept of negative 2.5. And I know that feels a little weird. And then we go up 1 and over 2. Now see if you can see that. Up 1, because we started a half, we're going to end at a half, and then over 2. And we end up with this line here, up 1 over 2. Looks like this. In the next one, I'm going to have a y-intercept of 3. So I draw a dot there, and then I go down 4, rise negative 4, and over 3. Well, look where the point is there. That's also our intersection point, just by chance. And what is that point? That point is 3, negative 1. So that's how we can solve by graphing. Now I'm going to move to sections 2.2 to 2.2, 2.1, and 2.3 and 2.4, and I'll finish with 3.7 in a second. Oh, I'm sorry, I forgot to give you your problems to solve. So for section 3.4, let me put this on page. For section 3.4, I would recommend that you practice with the slope y-intercept form. And you also have the perpendicular parallel lines, but I'm going to say on page 121. I'm looking at, this is several, 3, 5, 9, 13, 17, 19, 25, 31, 33. That is because this is probably the most critical, one of the most critical sections is that 3.4. For 3.5, the questions I have are for 3.5, page 129. I would like you to solve by substitution. And just disregard any other directions. I'm just saying solve by substitution, number 9 and number 15, and then by elimination. I'd like you to do 7, 9, and 11. So this is not as bad a piece as the other one. So at this point, I'd like you to do these problems, and when you're done, check them, and when you're done checking them, once you come back to the video, and we'll continue. So if you're still alive, you should probably have taken some form of a break, but hopefully at this point you're done with 3.1 through 3.5, which is a huge chunk. Section 2.1, section 2.1 is on, let me get my notes here, is just on linear, sorry about that, it's on one variable inequalities. Regarding one variable inequalities, really not much more than you did last year. What you're going to be doing is solving the inequalities, making sure that you remember that when dividing by or multiplying by a negative value, you need to switch the signs. Anyway, and in addition to that, just remember that the hollow dot means don't include, that means greater than, that means less than or greater than. We use a filled in dot to indicate less than or equal to, or greater than or equal to. So just a reminder that when you do graph it, that's what's expected from you. I do not have, one second here. I am confused about how this works here. There we go. Okay. I just want to make that look a little bit better. It looked a little confusing the way I wrote it. So hollow dot is, again, it's going to be less than or greater than. Hollow dot. And that's going to be greater than or less than or greater to filled in dot. I'll give you a quick example from the book, and just to give you a sense for what to expect. 5, 3 minus t less than 7 minus t. Distributing gives me 15 minus 5t less than 7 minus t. And I will try to get the t's on the left. I'll add t to both sides, gives me negative 4t. I'll subtract 7 from both sides, 15 from both sides, and I get negative 8. Now I'm going to divide by negative 4, which flips the sign. T is greater than 2. To graph this, I'm just going to find 2, and we'll put a hollow dot, and I'll shade in the direction of the inequality. And that's it. So the questions that you might want to practice for this will be on page 62. And the questions are 5, 7, 11, 17, and 27. So why don't you go ahead and give those a whirl and go ahead and then come back when you're done. Please check the questions again at the end of the book. Now we're on to section 2.2, graphing combined inequalities. This video is getting a little bit longer than I cared for. So I'm gonna try to keep these explanations brief. And if you have other questions, then you can try to address those while you study for this. This is on page 65. I will give you 2 examples, and one of them is the conjunction, and the other one is called the disjunction. And we'll start with the conjunction. And typically conjunctions are going to be given to us. So here's my conjunctions. Conjunctions use the word and. They usually represent where graphs overlap. And oftentimes they're written in a notation that shows the following. And let me just show you what I mean by this. We've talked about this in class, but wherever we have a situation where a low number is in the front and we have a large number at the end, and we have the inequalities are both less than, what happens is we're always going to have a conjunction. So when you see it in this form, assume it to be a conjunction. If it's a disjunction, it will have to use the word or. So let's go ahead and solve this one. There's 2 methods that we can solve, and you can go to my notes to find those 2 methods. What I'm going to do is use a method that seemed to be more popular with most people, and that's to solve the entire inequality as 1. So what we're going to do is we're going to subtract 5 from all sides, including, sorry about this, made a little bit of a mess, but minus 5 here and a minus 5 here. So I have minus 2 less than 2x less than or equal to 10. Now I divide everything by 2. If it was a negative, I'd have to switch the signs, but it's not. And so I have negative 1 less than x less than or equal to 5. So this becomes 2 inequalities connected by the word and. If I rewrite this one with the x to the left, I get x is greater than negative 1. And here I get x is less than or equal to 5. To graph both of those with the idea that it's going to be one and the other, we can graph them separately. Take a look at them. Let's take a look at, we have 5 and we have a negative 1. And we're saying that x needs to be bigger than negative 1, right? And it also needs to be less than or equal to 5. The combination of these 2 graphs produces one singular graph with the negative 1 here, the 5 here. We're going to have a dot, hollow dot, and a filled in dot, and all the numbers in between are the conjunction. If we have a disjunction, I'll do that one on the other side. Disjunctions use the word or. So an example of a disjunction would be 7 minus 2y is less than or equal to 1, or 3y plus 10 is less than 4 minus y. I'm running out of space there. Sorry about that. But anyway, let's go ahead and solve the first one for y. We're going to subtract y from both sides, so we get minus 2y less than or equal to negative 6. Dividing both sides by the negative 2. Remember, it's a negative 2. So y is now greater than or equal to positive 3. Now let's solve the other side. Let's get the y's to both sides. We get 4y if I add y to both sides. And then I'm going to subtract 10 from both sides. So it's going to be less than negative 6. Y dividing both sides will be y is less than negative 3 over 4. Oops. I mean 6, negative 6 over 4, which is y is less than negative 3/2. So graphing these two, I get the 3, and if this is 0 and negative 1 and negative 2, this would be negative 1.5 right here. And so what I'm looking for is, let's go ahead and graph these separately, as I have y is bigger than 3, bigger or equal to 3, and y is less than negative 3/2. So it's a hollow dot going in this direction. And in fact, that is the graph. It's a disjunction, so it can be either less than the negative 1.5 or greater than 3. So both graphs are part of the graph. So in order to practice these, you might want to try the following. So on page 67, I have, as practice, 5, 7, 13, 17, and 27. So why don't you go ahead and grab those, and when you're done, you can come back to the video and maybe take a little breather. Last section that we did on is 2.4, absolute value inequalities. Let's take a look at those, 2.4. Now, this video shouldn't serve as everything in your studies. If you have questions on absolute value inequalities, you would be best to go in and go ahead and take a look at your homework, look at the packet, and make sure that you understand the general ideas. But if I were to simplify things, this is what I did, and I tried to do it in the class the other day. And let's just start with an inequality. And let me give you just 3 examples that you might see. So example 1 is inequality, and this is just to remind you of how we were solving these in the past. To solve a basic inequality, first be sure to solve and get the inequality by itself. In fact, let me go ahead and reinvent this problem just a little bit. What I'm going to do is I'm going to add a factor of 2 over here, and I'm going to subtract 3 over here, which, sorry I cut you out, equals, I believe it's going to be, I'm going to guess it's going to be 13. So anyway, let's go ahead and get the absolute, the key thing is to get the absolute value all by itself first. So if I add 3 to both sides, I'm going to get 2 absolute value 3x minus 2 is equal to 16. And then I will divide both sides by 2, and I get 3x minus 2 is equal to 8. From here, what we do is we remove the absolute value sign, and we get 3x minus 2 is equal to 8. That's the easy one to write, and it's easy for the inequality. The second one, we need to make sure that we put a negative in front of the 8. We have 3x minus 2 equals 8. No, sorry, negative 8. So you're going to solve these two, and you're going to graph them. These both graph as dots. You get 3x is equal to 10, and x is equal to 10/3, which you could still find on the number line. The next one, I add 2 to both sides. I have 3x is equal to negative 6. Dividing by 3, x is equal to negative 2. So these are my two solutions. You would just graph them on the number line, and you'd be done. Negative 2 here, and 10/3 is 3.5. So you go negative 1, 0, 1, 2, 3, and a third somewhere over here is 10/3. So done. That's it. Just two dots. So to do the inequalities, let's do. Again, I'm going to assume you know to get the inequality by itself first. So let's look at the, let's look at an equation. Absolute value of 3 minus 2t plus 5 is less than 10. To do this one, again, get the absolute value by itself. We're going to subtract 5 from both sides. I don't like my line. There we go. And we get 3 minus 2t is less than 5. Absolute value. Now, once the absolute value is by itself, we can split it off into two inequalities. The first one, again, being the easy one, 3 minus 2t is less than 5. The second one, we need to remember to flip the sign and change the sign of the 5. So it's going to be greater than negative 5. Solving both of them, subtract 3 from both sides, I get negative 2t is less than 5, is less than 2. And therefore, dividing both sides by negative 2 flips the sign, and I get a 1. Take a moment and absorb that. Make sure that that you understand what just happened there. The next one, I subtract 3 from both sides. I get negative 2t is greater than negative 8. And I divide by negative 2 again. Flipping the sign, I get t is less than positive 4. This happens to be a conjunction, and as you'll see in a moment, it makes sense that it's a conjunction. You're going to see a graph that looks really familiar. You graph the 1 to the left, you're going to graph the 4 to the right, and we're looking at all numbers bigger than 1 and less than 4. The reason you would know that this is a conjunction is because we have the less than sign at the beginning. I should say the less than sign here is where we know that it's a conjunction. So the total graph, the final graph, will be graph the 1, graph the 4, and it's going to be a hollow dot, and all the numbers in between. Now, disjunction. A disjunction, you'll always see the word or, and or an equals. When it's equals, it's always going to be a disjunction. It also happens when we have this. I'm going to go. Let me give you 2z. Absolute value of 2z minus 1 is greater than or equal to 5. In this case, the greater than sign signals a disjunction or an or. To do this one, we can separate this into two different inequalities. So we got 2z minus 1. The first one we just copy right off without the absolute value signs. The second one, however, we need to make sure that we switch the sign, the absolute value sign, from greater than to less than or equal to, and switch the sign to a -5. Now let's solve each one separately, adding 1 to both sides. I get 2z is greater than or equal to 6. Z is greater than or equal to 3. Over here on the other side, I'm going to add 5 to both sides. I get 2z is less than or equal to -4. Z will be less than or equal to -2. Now, we graph. Go ahead and graph them separately. In this case, we have the -2 and we have the 3. And if I graph them separately, I need all values greater than or equal to 3 and all values less than or equal to -2. It looks like a disjunction. It is a disjunction. So practicing these, the ones that I have for you would be, and this is pretty recent material, but this is page 75. And we're looking at 9, 10, 15, 19, 20. Okay, so go at it. There's 2 even ones on this, so I may need to give you the answers to those. I can give you the answers to 10 and 10. I don't have the graph, but 10, the answer is going to be x is less than -2, and x will be greater than, or should say, x is greater than 2/3. For number 20, you would get the answer of 0 and 3. So check those out, and we'll have one last section, the most recent section, section 6, I'm sorry about that, 3.7. Because it's recent, I'm going to hope to not spend too much time on it, but we'll go at it in a minute. So go ahead and finish these problems and come back. Okay, this is our last section that we have on the test. This is section 3.7, and the name of the section was, I think it was compound linear inequalities. So, or just linear inequalities, I guess. Now, if you followed the instructions on how to graph a line, this stuff is not too bad. Just remember that whenever we have a greater than or equal to or less than or equal to, we use a solid line. With greater than or less than, we use a dotted line. And the solution is the shaded regions, the either double or triple shaded regions. So it's the shaded regions shared by all the graphs. I'll just graph one. And if you, and I'll give you some practice questions that you can try, and that'll be it for the test review. And I'm sure at this point you probably had it yourselves. But let's take a simple line. I'm going to go x is greater than or equal to 1, and I will also do the line y is equal to, oh, sorry about that. I'll go y is less than x plus 2. So let me graph the first line. Now, if they're not in slope y-intercept form, you might just go ahead and put them in there. The x is greater than 1 is a horizontal line, a vertical line, sorry, going through x equals 1. Looks kind of like this. And we're going to shade the greater than. So that's going to be this area here. So y is less than x plus 2. We're going to go to the y-intercept of plus 2, and when we have a slope of 1. So up 1 over 1. Up 1 over 1 produces a line that looks like this. And it's going to be a dashed line because in this case we're not equal to also. And in this case too, we're going to have a downward shade. Go ahead and pick something else to show the shading. And so the final solution ends up being, I'll just go ahead and make the final solution in red, is everything that's less than the line I just drew, and also greater than the y equals 1 line. So this is the region that they both share. Any point within that region is a solution to them both, is the solution to the system. So so in terms of practice, I have the following. So we're still recording. In terms of practice, I'm looking at you doing page 138. Page 138, number 5, 13, 15, 23, 25, and 27. They're all odd questions, so let's make sure that you check the answers in the back of the book. And for now, that's going to complete my review. I know that was extraordinarily long, but if you went through it, understood everything, you should be in pretty good shape, especially if you did the practice examples. So take care, have a great rest of your weekend, and I'll see you on Monday.